Asteroid tsunami. An Earth impact could send 400-foot waves to the U.S. coast. This was done in a simulation, and scientists have warned this could take place. The simulation was supposedly with the location near the east coast of North America. We know that we had an actual asteroid impact in the Gulf of Mexico, Yucatan Peninsula, and that was about 66 million years ago when we had the dinosaur extinction event. It was an extinction event that scientists say wiped out 75% of Earth's species. And this has happened many times in the past. Some say 460 million years ago, others say 250 million years ago. And we have maps of Earth impacts, confirmed Earth impact events from celestial bodies, comets, and asteroids. Now, an asteroid which NASA is monitoring to calculate whether a potential future Earth impact is possible could send 400 feet waves into the U.S. coast if it landed in the Atlantic Ocean. This is according to what a simulation had showed. Asteroid 2907, 1950, is a 1 kilometer wide, that's 3,600 foot wide, near Earth object, or NEO. So it's considered potentially hazardous asteroid, PHA. It's right now currently listed on the Sentry Risk Table, and that table monitors future possible Earth impacts with the highest cumulative Palmera rating. In 2002, NASA scientists calculated a 1 in 300 probability of an impact in the future, prompting experts to simulate the effects of such a strike. And March 16, 2880, is the day the asteroid is due to swing close enough to Earth that it could cause a problem, and that is a problem by the impact. And while the probability of a direct hit is small, asteroids this size and larger have struck the planet in its history, sometimes with, of course, catastrophic consequences. Now, if this asteroid does impact Earth, it's likely to splash down somewhere in the oceans, as the Earth is covered by 70% ocean. The Earth's surface planet is 70% water, so it has a bigger chance of hitting the oceans. Now, a computer simulation of an asteroid impact tsunami developed by scientists at University of California at Santa Cruz, USCS, showed waves as high as 400 feet sweeping onto the Atlantic coast of the U.S. And of course, it would go, this tsunami wave would go all the way across the pond into, of course, Greenland, Iceland, the Arctic, and Europe, Africa, and all the way across. Stephen Ward, researcher at the Institute of Geophysics and Planetary Physics of UCSC, and Eric Asfog, associate professor of Earth Sciences, reported their findings in Geophysical Journal International. Asteroids the size of 1950 DA have probably struck the Earth about 600 times since the age of the dinosaurs. 600 times. Dr. Ward and Dr. Asfog's study was conducted as part of a general effort to provide a rational assessment of asteroid impact hazards. Dr. Asfog, who organized a NASA-sponsored scientific workshop on asteroids in 2002, noted that asteroid risks are interesting because the probabilities are so small while the potential consequences are enormous. Of course, that means extinction-level event. Also, the laws of orbital mechanics make it possible for scientists to predict an impact if they are able to detect the asteroid in advance. He said it's like knowing the exact time when Mount Shasta will erupt. The way to deal with any natural hazard is to improve the knowledge base so we can turn the kind of human fear that gets played on in the movies into something that we have a handle on. For the simulation, the scientists chose an impact site consistent with the orientation of the Earth at the time of the predicted encounter, that is, the Atlantic Ocean, about 360 miles from the U.S. coast. Dr. Ward explained that the 60,000 megaton blast of the impact could vaporize the asteroid and blow a cavity into the ocean 11 miles across and all the way down to the seafloor, which is about 3 miles deep at that point. Now, if it hits the seafloor, obviously you know what that means. That has another consequences, of course, geological events. When you have something that fast and that hard hitting a rock, obviously you're going to have earthquakes and volcanic eruptions. Now, Dr. Ward explained that the 60,000 megaton blast of impact could vaporize asteroid and blow a cavity in the ocean 11 miles across all the way down to the seafloor. The blast also excavates some of the seafloor, and the water would then rush back in to fill the cavity, and a ring of waves sent out in all directions. He said, in the movies they show one big wave, but you actually end up with dozens of waves. The first ones to arrive are pretty small, and they gradually increase in height, arriving at intervals of 3 or 4 minutes. 2 hours after impact, the study claimed 400-foot waves would reach beaches from Cape Cod to Cape Hatteras, and by 4 hours after impact, the entire East Coast would experience waves at least 200 feet high. It would take 8 hours for the waves to reach Europe, where they would come ashore at heights of about 30 to 50 feet. At its greatest estimates, NASA predicted asteroid 1950 DA represent a risk 50% greater than that of any average hazard from the present era to the year 3000. But since 2003, the estimates, that's with this simulation that took place then, the estimates have been updated several times, with the latest in 2015 placing the odds at 1 in 8,300 to occur. Despite this, the space agency has reiterated more will be known after its next close approach, which happens quite soon. It will be in February 5th, the 5th of February 2021. That's in about 6 months, 7 months. Now, updating the risk is necessary because not enough is known about the physical properties of this asteroid. For example, radar data suggests 2 possible directions for the space rock's spin pole. If one pole is correct, solar radiation acceleration, that's the Yarkovsky effect, could significantly cancel thermal emission acceleration, meaning probability would then be close to a maximum 0.33%. If the spin pole is instead near the other opposite solution, there would be little chance of collision. NASA says the situation is similar to knowing you have a coin that is biased, so one side will land up 80% of the time, but you don't know which side. You can only say that when you flip the coin, the chance of heads is 80% or 20%. And occasionally asteroids can make close approaches to Earth, but this does not mean they're likely to strike. Note that a close passage astronomically can be very far in human terms, millions or tens of millions of kilometers. Occasionally asteroids' orbital paths are influenced by the gravitational tug of planets, which cause their paths to alter. That's the Yarkovsky effect that causes the celestial body from the difference in temperature on the surface to spin on its axis, and it goes off its trajectory. The effect occurs when a space rock is heated in direct sunlight, cools down, and releases radiation to the surface. There is also the possibility of asteroids or fragmented asteroids being redirected towards us after cooling with other space rocks, after colliding with other space rocks. Now, other asteroids listed on NASA's database of Earth close approaches are deemed safe, and NASA's tracking systems have ruled out all possibility of danger. NASA claims because of the ongoing search efforts to find nearly all the large NEOs, objects will occasionally be found to be on very close Earth approach trajectories. Great care has to be taken to verify any Earth collision predictions that are made. Given the extremely unlikely nature of such a collision, almost all of the predictions will turn out to be false alarms. But if an object is verified to be an Earth colliding trajectory, it seems likely that this collision possibility will be known several years prior to the actual event. That's assuming that they already know that that asteroid exists, because some asteroids are only found a day or two before they come into us. This is by Callum Hoare on Express UK. If you'd like to join me on my Patreon account, you will hear content not covered by mainstream media. These riveting stories will be based on my research, and I will state my opinions and give my personal insight on diverse and controversial subjects and world events not covered by mainstream media, and not supported by YouTube guidelines. So whatever I have on my Patreon, most of those will not be on my YouTube channel. Please consider becoming a member today. More of the most significant and important videos will be on my Patreon channel. Your support helps me to continue my research and keeps this YouTube channel alive. And we depend on your support, your generous charity, because we help economically challenged families here in Athens, Greece, in Kapota, and we also help the young generation with university tuition and the community around our church. Thank you.